Assalamualaikum and hi. My name is Nur Alia binti Zulkifli. I will explain to all of you the three-phase balance load of RL series connection. So this is the complete wiring. Okay, for the procedure, firstly, you have to connect the resistive load of 750 ohm in series to the inductive load in the star configuration and set the following inductance levels of 1.2 Henry, 2 Henry and 3.2 Henry in succession one after the other. And then you have to switch on the variable transformer and set a first voltage of 230 volt. Next, turn the power switch on and the last one, you can read all the values directly from this power quality meter. But you have to remember, modifications to the circuit only permitted when the voltage is off. Okay, this is the procedure that I have explained before. Alright, let's take a look at the result. Firstly, what we can see here is the value of resistance. The value of resistance for 1.2, 2 and 3.2 Henry are all same, which is 750 ohm. Next, the value for U1N and U12 will decrease when the value of inductance increase. And then we have the value of current. The value of current for 1.2 Henry is 0.26, for 2 Henry 0.23, and for 3.2 Henry is 0.18 ampere. Next, we have the value for power. The value of power will decrease when the value of inductance increase. Firstly, we get 54 for 1.2 Henry, 41 for 2 Henry, and 26 watt for 3.2 Henry. And then we have the reactive power. The value of reactive power for 1.2 Henry is 25, 2 Henry we get 31, and 3.2 Henry we get 31 also. And then we get the value for reactive power. Apparent power. Okay, for the 1.2 Henry we get 59, for 2 Henry we get 51, and 3.2 Henry we get 40. Okay, next we take a look at the total of power, total of reactive power, and total of apparent power. Okay, so for the total power, they will decrease when the value of inductance increase. Firstly, we get 161 for 1.2 Henry, 123 for 2 Henry, and 78 watt for 3.2 Henry. And then for the total of reactive power, we get 76 for 1.2 Henry, 93 for 2 Henry, and 91 for 3.2 Henry. For the last one, for the apparent power, it will decrease when the value of inductance increase. Okay, firstly we get 178 for 1.2 Henry, 154 for 2 Henry, and 120 for 3.2 Henry. Next, we get the total of cos theta. Okay, so 0.9 is for 1.2 Henry, 0.8 we get for 2 Henry, and for 3.2 Henry we get 0.65. So for the last one, we have to calculate the value of reactance, which is in unit of ohm. Okay, for 1.2 Henry, we get 369.82. For 2 Henry, we get 627.44. And the last one, for 3.2 Henry, we get 956.79. Okay, this is the last one. The question asks us to choose the correct phasor diagram for RL series connection. As you can see here, this is the answer for this question. Okay, that's all.
Assalamualaikum and hi everyone. So firstly I need to introduce myself. My name is Muhammad Hafiz bin Noh and I from S21. So today I would like to explain about an experiment, three-phase balance load RC series connection. So when I say RC series connection, you already had in mind that RC represent resistor and capacitor series capacitor. So it connect to series connection. So let's go to the circuit. Yes, this is the circuit. So firstly, I will tell you the procedure. Firstly, we need to connect the resistive load with a resistor of 750 ohm in series with the capacitive load in star configuration and set the capacitance to 2 microfarad, 2 microfarad, 4 microfarad, and then 8 microfarad, one after the another, one after the other. So firstly, we need to set to 2 microfarad, 2 microfarad, 2 microfarad, 2 microfarad. So after you will get the result, you will change to 4 microfarad, and then after that you change to 8 microfarad. So so after we connect the connection and the series connection, we switch the variable 3-phase power supply on and set the phase voltage to 230 volts. And then you turn on the power switch on. You can read all the values directly from the power quality meter. So after you get the 2 microfarad, 4 microfarad and 8 microfarad value, you can compare the result. So let's go to the result. Yeah, this is the result that I get. So first, you can see this 2 microfarad, 4 microfarad and 8 microfarad. So the resistive load is same. The resistor value is same, is 750, 750 and 750. So while the voltage is 392 for 2 microfarad, and then it decreased by 391 for 4 microfarad, and same as 8 microfarad 391. So we see at the current is 0.13 for 2 microfarad, 0.21 for 4 microfarad, and 0.27 for 8 microfarad. So as you can see, the value is increased due to the increase of capacitor value. So the power is also increased from 2 microfarad 13 watt to 333 watt, and then 554 watt. So it increased also due to the capacitor value increase. So let's go through the reactive power. So, reactive power, as you can see, 27 at 2 microfarad, and then it's increased to 55 for 4 microfarad, and then it decreased to 28 for 8 microfarad. And then we see the apparent power. The apparent power is increasing from 2 microfarad to 8 microfarad is 30, 48 and 61. So the total power increased from 2 microfarad to 8 microfarad. And then reactive power also increased for the from 2 microfarad 81 to 105 at 4 microfarad, and then it decreased again to 86 microfarad. And then to apparent power, we see apparent power is 90 for 2 microfarad, and then 144 for 4 microfarad, and then 184 for 8 microfarad. So it increased. While the cos theta phase is 0.43, also increased due to the capacitor load value increase. And then let's see reactance. Okay, the reactance we calculate using the formula given, and we get for 2 microfarad is 1592.5 and ohms, and then for 4 microfarad is 795.46 ohms, and then for 8 microfarad is 397.73 ohms. So it decreased when the value of capacitor is increased. So let's go to the next, the final slide. So let's go. Okay. So the discussion led us to choose the correct phasor diagram. So when you see RC series connection, so when you see RC, so it involve resistor and capacitor only. So it don't involve inductor. So when uh, capacitor, as you know, is lagging, right? So lagging, inductor is leading. So the capacitor must have negative value. So it must have negative value. So we see at the first phase diagram, the capacitor is increased. Is positive. So it's not the correct answer because we know capacitor is negative value. So we see at the second one. The second one is the correct one because the capacitor is negative, negative value. So it might be. So uh, let's go to the final one before we decide the true answer. So the final one is UL. So L is mean by inductor. So there is no inductor involved in our experiment. So we can decline this as the diagram. So we choose this one. So this one is the answer, is the correct phasor diagram. So that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Zainuddin Belabid. Okay, today I want to talk about RLC series connection. So, what is a RLC? An RLC circuit is an electrical circuit consisting of a resistor, an inductance, and a capacitance connected in series or in parallel. So the name of the circuit is derived from the letter that are used to denote the constituent component of this circuit, where the sequence of the component may vary from RLC. So the circuit form a harmonic oscillator for current and resonance in a similar way as a LC circuit. Introducing the resistance increase the decay of this oscillation, which is also known as damping. So the resistance also reduces the peak resonance frequency. So in ordinary condition, some resistance is unavoidable even if a resistor is not specifically included as a component. An ideal pure LC circuit exists only in the domain of superconductive. A physical effect demonstrated to this point only at temperature far below ambient temperature found anywhere on the Earth's surface. Okay, so for the lab, we set up the following circuit. So this is the circuit, the star configuration RLC series connection. So for the procedure of this lab, first we connect the resistive load 715 in series with the capacitance load microfarad, and this is series with the inductive load 1.2 Henry connected in star configuration. So the next, we switch on the available 3-phase power supply and set a phase voltage of 230 and turn the power switch CO3301 5P on. So lastly, we read all the value directly from the power quality meter, and then so the formula is for SLC equal QLC over 12N. So after we read the meter, so this is all data that we get from this lab. So that can you see, we have capacitance, inductance and resistance. So we also have a power and all lah, power factor, LC. So we can get all the data from the meter. Okay, from the lab sheet, we also answer the all question in this lab sheet. So for example, we choose the correct phasor diagram, so the answer is C. So that's all for today. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ashraf bin Sarwi. So for this lab, I want to present to you about a conclusion for this lab. In conclusion, for the RL series connection, when the inductance increase, the real power will be decreased. Next, from the data also, the current for each phase also has a difference, about 0.04 ampere to 0.05 ampere. The current at the phase 1, which has 1.2 inductance, have highest value, which is 0.26 ampere. Next, in the RC series connection load, the power will increase when the value of the capacitance increase. This shows that the value of the capacitance is very important to determine the power. As the data also, the value of the capacitance is directly proportional to the value of power factor. The circuit will be unstable when the value of the power factor reach or nearest to 1. Lastly, for RLC series connection, the value of capacitance is directly proportional to the value of the power. As the data, the power factor reach 1 when the value of capacitance is at 4 and 14 microfarad. That's all from me. Thank you.